Hi, in this video we will be talking about polynomial functions. We will discuss the types of polynomial functions, the graphs, zeros, and a lot of other stuff. Like, let's look at this graph here. This graph represents a polynomial function, and we can tell from the graph we have how to describe that polynomial function. So if I'm required to describe the polynomial function, I'm going to basically look, the first thing we need to look at is how many times does this graph intersect with the x-axis at this point, and that point. So if it intersects with the x-axis 3 times, you can tell that the degree of the polynomial function is cubic. So this graph represents a cubic polynomial function. What else does it represent? The second thing you should be looking at is the end behavior. Now we can say that the end behavior of this function, as you can see here, it starts down at the left, so it starts down. So this is the behavior from this end. Then it ends upwards, so the behavior on the other end is up. So now we describe the graph regarding its degree, its cubic function, and regarding its end behavior. The next thing you should be looking at is the turning points. How many turning points does this graph have? What do we mean by turning points? Now the graph here is increasing until it stopped at this point, then it started decreasing. So this here is a turning point. Now it started decreasing, then it changed its behavior again and increased. So this is another turning point. So we can say that there are, for this graph, 2 turning points. Now any graph has at most, number of turning points at most is always less than the degree by 1. So if the degree here is 3, then the number of turning points is less than 3 by 1, which is 2. Okay, so we can tell how many turning points we have from the degree of the function. Now it doesn't always show, because of different reasons like multiplicity and imaginary roots. It doesn't always show that there are 2 turning points, but I know for sure that the most number of turning points is 2. So it's going to be 2 or less, but it can never be more than 2. So now we have discussed the degree of the function, the end behavior of the function, and the turning points. Next thing we need to discuss is the increasing and decreasing intervals. Now let's look at this graph here. We describe the increasing and decreasing intervals always on the x-axis, not on the y-axis. So at this end of the x-axis you have negative infinity, right? And on that end, after the 10 and we go on, there is positive infinity. So we can say that the graph increases. I know that it does increase. From where? Now this is going down endlessly, like forever. So it increases from negative infinity until this point. At this point it will stop increasing. So you can write from negative infinity until, or 2, it does not matter, almost negative 1. Now you're reading the points on the x-axis, not anywhere else. Like this point here is almost at negative 1. Okay? Then it decreases, right? So then it decreases from where? From negative 1 to what? It continues decreasing until it reaches that point. Now you need to know how much is the x value at that point. So it's almost, well, it's not really accurate, but almost to 2. Okay? Then it started increasing again. Increased from where? From that 2 until forever. Now this graph is going to continue increasing forever, so until infinity. So in this part here we saw that we can describe the graph starting from its degree to its end behavior, turning points, and we can describe the increasing and decreasing behavior. Now, if you understood this, you can practice describing this graph as well. Now, we are going to write the polynomial function, but for now, let's just describe the graph. In the next video, we will see how we're going to turn this graph into a polynomial function in standard form. Thanks for watching.